Alrighty, so we're going to start solving some log equations in this half of 7.5. Last time we were doing some exponentials, now it's logs. And they're very similar to each other in some ways, but also different. Alrighty, so this first one here, we've got x equals log base 2 of 16. Well, I think a lot of you could probably do this one in your head like Jason Derulo, because what all we have to do is think, well, 2 to what power gives me 16? Or if you were to, rewrite this, you'd have 2 to the x equals 16. You could think about that. Okay, well, I know that x equals 4. Now, this is the type of problem that would be on a non-calculator section. Even though you could do the math alpha math and put 2 and 16 and get 4, these numbers here are nice numbers to where we're like, hey, you should be able to handle this without a calculator. You can also think of it as 2 to the x equals 2 to the 4th, because you can rewrite 16 as 2 to the 4th. And then you see that x equals 4 that way as well. But just make sure you can handle something like that without a calculator. Now this one, I don't know. I mean, it looks all scary and stuff. I'm like, what? Do I need to plug it in my calculator? Oh, man, I don't think so. Well, I've got log base 10, because when it's not written, we know it's 10. And if I rewrite this in exponential form, 10 to the 4th equals x. Well, 10 to the 4th is just going to give me 10,000. So look at that. No calc. Holla. You. Alrighty, now we got some more solving with logs. We got log base 3 of 9 equals x plus 3. Well, log base 3 of 9, I know that's just 2 is x plus 3. And then if I subtract, I'm going to get x equals negative 1. Now, we do need to watch out for negative numbers here and there. Now, not necessarily that x is negative, but we do need to watch out for certain things. We can't take the log of a negative number. With x being negative 1, I'm all good. X is right here. Negative 1 plus 3 is 2. It all checks out just fine. But if I end up taking a log of a negative, now we got issues, and we'll see that at some point. Alrighty, so I've got log base 3 of x plus 2 minus log base 3 of 6 equals 1. And up here it says, recall the properties. Well, when we're subtracting, if I condense it, I'm going to have log base 3 of x plus 2 over 6 equals 1. Okay. I think I could write this in exponential form, yeah? So I'm going to have 3 to the first equals x plus 2 over 6. Well, 3 to the first is just 3, right? So we can take that off. And if it helps, you could always put this over 1. Well, what do I do when I have two fractions side by side or equal to each other? I can cross multiply. Let's do that. So I'm going to have 3 times 6, 1 times x plus 2. And then I'm going to subtract 2 and I get 16. Awesome. And I do need to make sure that I'm taking logs of positive numbers. If I plugged 16 in for x, I have log base 3 of 18. We're all cool. We all good. Awesome. If I ended up getting like x is like negative 16, then I'm taking the log of negative 14, and that's not okay. That would not work, okay? And we've seen solutions where we do everything right, they don't work, we call them extraneous solutions. But again, see that in the future at some point. All right, this next one here, we're going to change this actually to x minus 6, all right? It has to do with how it's going to work out in the end. But let's think about this now. This time I've got addition, but I'm going to use the properties once again. Addition condenses to multiplication. So I have log base 3 of x times x minus 6, and that equals 3. Now I can put this into exponential form, and I've got 3 to the third equals x times x minus 6. So I've got 27 equals x squared minus 6x. Well, what can I do when I have something like this? I've got squared, I got an x, I got a 27. All factor, that's right. So we're going to have 0 equals x squared minus 6x minus 27. So what multiplies to negative 27 and adds to negative 6? Well, that would be negative 9 and positive 3. Cool. So I'm going to have x equals 9 and x equals negative 3. Now we need to check some stuff before you wreck some stuff. You know what I'm saying? So 9, if I plug 9 into my original, which is up here, let me make sure we got it all. Okay. If I plug 9 in, I get a log base 3 of 9. That's cool. and I get log base 3 of, well, 9 minus 6, positive as well. So I'm taking the log of positive numbers. That's good. If I plug in negative 3, however, I'm taking log base 3 of negative 3. I can't take the log of a negative number, so in this case, this does not work. If it doesn't work in any spot, it doesn't work. I mean, it also wouldn't work over here because I'd have negative 3 minus 6 is negative 9. But even if this were positive 3, even if this was a positive 3, 3 minus 6 would give me a negative number. It still wouldn't work. So even if x was positive in this case, it still wouldn't work. So it's not about x being negative or positive. It's about when you plug it back into the orig. Okay? So only 9 for this one. Logs, can't take the log of a negative number. Exponents can be negative, positive, doesn't really matter. Just logs we got to watch out for. So here's the big warning. Beware. You may not take the log of a negative number. Check for extraneous roots. So clearly, this is important. I would write that down. Okay? Always check.